Hello everyone and welcome to Brilliant Mind series. Brilliant Mind series' core objective is to design math tutorials for B7, B8 and B9. Previously JHS 1, 2 and 3 based on the new math curriculum to develop critical thinking and problem solving, communication and collaboration, and creativity and innovation among students across the world, most especially Ghana. The topic is number and numeration system. In this video, we are going to learn something about using base 10 blocks to write numbers, finding the total number of blocks, find how many of each 100, tens, and ones blocks you need to solve math problems. Use multiples of tens, 50s, 100s, and 200s to solve problems. Use tokens or paper-made currency notes such as 20 Ghana cedis, 50 Ghana cedis, 100 Ghana cedis, and 200 Ghana cedis to work out how many of each denomination will be required to model given amount up to 1 billion. Determine combinations of 50 Ghana cedis, 100 Ghana cedis, or 200 Ghana cedis note that make up 1 million. Compare and order whole numbers more than 1 billion and represent the comparison using greater than, less than, or equal to. Identify numbers which are, for instance, 500,000 more than or less than a given 8-digit or 9-digit number. Identify read and write numbers in a given position in a number chart. Round off up down whole numbers more than 1 billion to the nearest hundreds, 100,000, 10,000s, thousands, hundreds, and tens. Round off up and down decimals to the nearest tenth, hundredth, and thousands, finding a value of a digit in decimals. And lastly, difference between the round up and round down concept. This is what we call multi-base arithmetic block. Multi-base arithmetic blocks are mathematical manipulative used to learn basic mathematical concepts such as addition, subtraction, place value, and counting. This represent hundreds, that represent tens, and that represent ones. Using base 10 blocks to write numbers. Illustration 1, we have tens and ones. So as you can see, we have 6 tens, 1, 2, 3, 4, 5, 6. 6 tens, and then 1, 2, 3, 4, we have 4 ones. On my right hand side, we have 9 tens, and then we have 6 ones. Review exercise 1, write the number that each set of blocks represents. As you can see, we have hundreds, we have tens, we have ones. How many of them do you see? You just put them here. And on my right hand side, the same thing. How many hundreds do you see? How many tens do you see? And then how many ones do you see? And then we have how many blocks will make a billion. We are going to find the total number of blocks. We have 2 tens and we have 4 ones. When you put them together, we are going to get 24 because 2 tens plus 4 ones will give us 24. Next, we have 100 of block, and then we have 3 tens here, and then we have 2 ones. So we are going to have 100 plus 3 tens plus 2 ones, and that will give us 132. Next, we have 110, we have 8 ones. So when we put them together, we are going to get 18. And on my right hand side, we have review exercise 2. You are going to find how many hundreds, how many tens, and how many ones do we have, and then we put them together as it has been illustrated. Next, we are going to look at how many hundreds, tens, and ones blocks you need to solve the following. The first example is 8,568,210. So how many hundreds are we going to use? Please do not repeat them. Once you use hundreds, you don't use it again. Once you use tens, you don't use tens again. And then once you use ones, you don't use ones again. You are required to use them once. So we have 8,568,210. So let's separate 80 million here. We are going to use hundreds. So when you divide 8 million by 100, you get 80,000 of 100 blocks. Then we move to 568,000. So 568,000 divided by 10, we get 56,800 of 10 blocks. And then lastly, we have 210. So 210 divided by 1 block or ones, we get 210 blocks of ones. Here we have 2,410,000,000 370,190. So when we separate 2,410,000,000, as you can see here, and then we divide it by 100, we are going to get 24,001,000,000 of 100 blocks. Then we move to tens. We consider 370,000. So when we divide 370,000 by 10, we get 37,000 of 10 blocks. And then it will be left with 190. So 190 by 1, that is ones, or the one block, we get 190 blocks of ones. Review exercise 3. Find how many of each hundreds, tens, and ones blocks you need to solve the following. These are the questions. I decided not to add answers to them. Next, we are going to use multiples of tens, 50s, 100s, and 200s to solve problems. Illustration 1. Use multiples of 10, tens, 50s, 100s, and 200s to solve the following. So first question, we have 1,000. How many 200s do we need? So we need 2 of 200. That will be 400. And then when we subtract 400 from 1,000, we get 600. How many hundreds do we need? We need 3. So when we multiply 3 by 100, we get 300. 300 subtracted from 600, we get 300. How many 50s do we need? We need 4. 4 by 50 gives us 200. And then when we subtract 200 from 300, gives us 100. How many tens do we need? We need 10. So 10 times 10 gives us 100. When we sum them up, it gives us 1,000. That is equal the answer. When you sum them up and the answer here is different from the given question, you have to redo it. B, we have 2,300. So how many 200s do we need? We need 5. And 5 by 200 gives us 1,000. Then we subtract 1,000 from 2,300. That will give us 1,300. How many hundreds do we need? 8. So 8 of 100 will give us 800. 800 subtracted from 1,300 gives us 500. How many 50s do we need? We need 8. So 8 by 50 gives us 400. 400 subtracted from 500 gives us 100. How many tens do we need? 10. So when you multiply 10 by 10, we get 100. When you sum them up, you get 2,300. That equals to the answer. And then C, we have 1,020. So how many 200s do we need? 3. And that will give us 600. 600 subtracted from 1,020 gives us 420. How many hundreds do we need? We need 2. So 2 by 100 gives us 200. And therefore 200 subtracted from 420 gives us 220. How many 50s do we need? 3. And 3 by 50 gives us 150. 150 subtracted from 220 gives us 70. How many tens do we need? 7. So 7 by 10 gives us 70. When we sum them up, we get 1,020. D, we have 5,560. How many 200s do we need? 20. So when we multiply 20 by 200, it gives us 4,000. 4,000 subtracted from 5,560 gives us 1,560. How many hundreds do we need? We need 10. 10 by 100 gives us 1,000. When we subtract 1,000 from 1,560 gives us 560. How many 50s do we need? 11. 11 by 50 gives us 550. When we subtract 550 from 560 gives us 10. How many 10s do we need? Only 1. That gives us 10. When we sum them up, we get 5,560. Alternatively, we can also solve the same question this way. How many 200s do we need? 15. 15 by 200 gives us 3,000. When we subtract 3,000 from 5,560 gives us 2,560. How many hundreds do we need? We need 20. 20 by 100 gives us 2,000. 2,000 subtracted from 2,560 gives us 560. How many 50s do we need? 10. When we multiply 10 by 50, it gives us 500. When we subtract 500 from 560, it gives us 60. How many 10s do we need? 6. So 6 by 10 gives us 60. When you sum them up, we get 5,560. That equals to the question. Review exercise 4. Use multiples of 10s, 50s, 100s, and 200s to solve the following. And that is a question. A, B, and C. Next, we are going to use 20 Ghana cedis, 50 Ghana cedis, 100 Ghana cedis, and 200 Ghana cedis to work out how many of each denomination will be required to model given amount up to 1 billion. Question 1. How many 200 Ghana cedis will make 185 million? This is simply by dividing 185 million by 200 Ghana cedis, and that will give us 925,000. And therefore, 925,000 of 200 notes will make up 185 million. Illustration 2. How many 200 Ghana cedis do you need to buy a television set which costs 0.45 million? Here, to get the answer, just multiply 0.45 by 1 million, and that will give you 450,000. So still, we are going to divide 450,000 by 200, and that will give us 2,250 Ghana cedis. Hence, you need 2,250 notes of 200 Ghana cedis to buy a television set, which costs 450,000 Ghana cedis. Review exercise is here, and these are the answers. Next, we'll be looking at determining combination of 50 Ghana cedis, 100 Ghana cedis, and 200 Ghana cedis note that make 1 million. A man has 50 Ghana cedis, 100 Ghana cedis, and 200 Ghana cedis. How many of each note does he need to buy a car which costs 1,500,000? So we have how many 200s does the man need? 5,000. When we multiply 200 by 5,000, it gives us 1 million. We subtract 1 million from the 1,500,000. How many hundreds does the man need? 4,000. When we multiply 100 by 4,000, it gives us 400,000. How many 50s does a man need? 2,000. When you multiply 550 by 2,000, it gives us 1 million. Therefore, the man needs 5,000 of 200 notes, 4,000 of 100 notes, and 2,000 of 50 notes. When we sum them up, it will give you 1,500,000. Illustration 2. Akwele went to Kaneshi market with 50 Ghana cedis and 200 Ghana cedis. If she wanted to buy a bag of rice which cost 525,000, how many of each notes did she need? 200 notes of 2,500 gives us 5,000. Gives us 500,000, sorry. And then how many 50 notes does she need? She needs 500. So when you multiply 50 by 500, it gives us 25,000. Therefore, Akwele needs 2,500 of 200 notes and 500 of 50 notes to be able to buy a bag of rice, which costs 525,000. Review exercise 6. This is the table, and that's the continuation of the question. I decided to provide one of the answers, and then the rest. So look it up on your own, try and solve it and see whether you get the same answer. This is the continuation from the back from the question we just looked at. Compare and order whole numbers. Compare and order whole numbers more than 1 billion and then represent the comparison using greater than, less than, or equal to. First, we'll be looking at skip counting forwards and backwards in 25s, 50s, 250s, beginning from 1,000. So forward counting of 25 up to 500. So you can see we are going to count, but this time we are going to count by 25s. So 25 plus 25, 50. 50 plus 25, 75. 75 plus 25, 100. 100 plus 25, 125. 125 plus 25 gives us 150. In that order, up to 500. Then we come to backwards counting of 50 beginning from 1,000. So there's 1,000. 1,000 minus 50 gives us 950. 950 minus 50 gives us 900. 900 minus 50 gives us 850. 850 minus 50 gives us 800. And this is what we call backward counting. Review exercise 7. Copy and complete the table below by counting backwards of 25. So you fill in the blank spaces. Next, we move to identify numbers which are, for instance, 500,000 more than or less than a given 8-digit or 9-digit number. Illustration 1 is 1,295,800,000 more than or less than 1,295,300,000. Sorry, 1,295,300,000. And by how much? So solution. When we look at the first figure and then the second figure, we could see that the first figure is 500,000 more than the second figure. How do we get that? We get that by subtracting 1,295,300,000 from 1,295,800,000, and that will give you 500. Next question we have is 345,800 more than or less than 354,800, and the answer is 345,800 is 9,000 less than 354,800. We have arrived at the answer by subtracting 345,800 from 354,800. Compare and other whole numbers more than 1 billion and represent the comparison using greater than, less than, or equal to. Now, looking at this diagram, you could see that the crocodile is trying to bite 15. Why? Because 15 is greater than 12. That is why the crocodile is trying to bite a 15. So 15 is greater than 12. On the next diagram, you can see that the crocodile has now turned right toward 24. 24 is greater than 20, which is why the crocodile is trying to bite 24. So always try and then position the symbol to swallow or bite the bigger number, be it on the left side or right side. And this is greater than, that symbol is less than, and that is equal to. Illustration 1. Compare the following numbers using greater than, less than, or equal to. Now, if you look at the number on the left and the number on the right, you can see that they are the same, and therefore the answer is equal sign. Then this and that, you could see that the one on the left is greater than the one on the left, and therefore greater than. Remember that I said always place the symbol to bite the bigger number. And then thirdly, we have this figure and we have that figure. This is 1,235,786,100. You could see that this number is greater than the number on the left, and therefore the greatest sign symbol is positioned towards the bigger number, or the greater number. The symbol is biting the number which is greater. Illustration 2. The population of Ghana was 8,363,710 in 2010. It was expected to increase by 1,201,987 by the end of 2012. What was the expected population of Ghana at the end of 2012? And the next question, by how much is the population in 2010 greater or less than the population in 2012? Use the symbol to illustrate your answer. So solution. If a certain number is increased by this, it means we are going to add this and that. So expected population in 2012, we put 2010 and 2012 together, then we get 9,565,697. So you can see population 2010 here and the population 2012 here. What is the difference? So we are going to strike the difference. So when we find the difference, we get 1,210,987. Therefore, the population in 2010 is 1,201,987 less than the population in 2012. So the symbol will always bite or face towards the bigger number. And that is review exercise. These are the questions, these are the answers I have provided. Next, we are going to look at identify read and write numbers in a given position in a number chart. This is a number chart. They will always give you the number charts, and then they will ask you questions based on the number chart. First question, Which number is on the right of 3,187,500? This is 3,187,500. Which number is on the right? This is right. So 3,687,500 is on the right of 3,187,500, and that's the answer. Write the number in words. So 3,687,500. Question 2. 187,500 is on the right of 687,500. True or false? So the answer is false. So that's the review exercise. These are the questions and those are the answers. Round off up down whole numbers more than 1 billion to the nearest 100,000, 10 thousands, hundreds, and tens. Now, for example, we have 9,345,217,608. Now, note the following. The first figure counting from the right is called units. The second figure is tens. The third figure is hundreds. The fourth figure is thousands. The fifth figure is tens of thousands. The sixth figure is hundreds of thousands. The seventh figure is millions. The eighth figure is tens of millions. The ninth figure is hundreds of millions. And the 10th figure is billions. So on my right hand side, I've done it in a way that will help you understand it properly. So 8 is the first number on the right, and that is units, that is tens, that is hundreds, thousands, tens of thousands, hundreds of thousands, millions, tens of millions, hundreds of millions, and then billions. Now, let's look at general rule for rounding. Now, when you are rounding off rule number 1, if the number you are rounding is followed by 5, 6, 7, 8, or 9, round the number up. What this means is that we will take 1 if the number is 5, 6, 7, 8, or 9 to the next number on the left. For example, 561 rounded to the nearest 100 is 600. Why? Because this is more than half. These are the numbers. If the number you are rounding is followed by 5, 6, 7, 8, or 9, round the number up. Rounding it up means you are going to borrow 1 from either 5, 6, 7, 8, or 9 to the next number on the left. So we borrowed 1 from here and added it to 5. That gave us 600. This is because 561 is closer in value to 600 than to 700. Second rule, if the number you are rounding is followed by 0, 1, 2, 3, or 4, round the number down. What this means is that you don't borrow any number from 0, 1, 2, 3, or 4. For example, 54 rounded to the nearest 10 is 50 because this is less than 5, 6, 7, 8, or 9. And so you don't borrow it. You don't borrow 1 from this number. So it will be 50. This is because 50 is closer in value to 54 than to 60. Rule number 3. When rounded off to the nearest Ghana city, for example, 2 Ghana cities, 75% becomes 3 Ghana cities. This is because 2 Ghana cities, 75% is closer to 3 Ghana cities than to 2 Ghana cities. Illustration 1. If the distance between the Earth and the Sun is 92.65 million miles, round it off to the nearest miles. When we round it off to the nearest miles, this is 5 or more. So we borrow 1 from here and we add it to this, making 3. So we are going to get 93 million miles. Illustration 2. Express 1,879,653 to the nearest hundreds and then 10,000. To the nearest 100,000, it will fall here. This is 7. So when you borrow 1 from here and add it, making 9. Therefore, it will be 1,900,000. To the nearest 10,000, it will be here. So this is 9. When you take 1 from here, we add it to the 8, 7, making 8. So we're going to get 1,880,000. Illustration 3, that is BECE 1994. Write 35,632 correct to the nearest 1,000 cities. Which number falls within 1,000 cities? 5. And therefore the number here is 6. So we borrow 1, add it to the 5, making 6. And therefore you're going to get 36,000 Ghana cedis, as it is written here. BEC 2008, round 8,921,465 to the nearest 100. 100 falls here. 100 falls here. So when we take 1 from 6, we add it to the 4, making 5. So it's going to be 8,921,500. And that's review exercise 10. That's a question. That's the answer. And then we have another question here, and these are the answers. Round off up and down decimals to the nearest tenths, hundred, and thousands. Now, for example, the figure we have here is 934.521. The whole of this is 934 is the whole number. The first figure here is tenths. The second figure, which is 2, is hundredth. And the third figure, which is 1, is thousand. So 10, hundreds, and thousand. 10 times 10 gives you 100. 100 times 10 gives you 1,000. That is why we have 10, 100, and 1,000. Know the following. For any number with a decimal part, the first decimal place is called the tenths. The second decimal place is called the hundreds. The third decimal place is called the thousand. This explains what I just said. Illustration 1. Round 486.3685 to the nearest tenths. Remember, to the nearest tenths falls here. This is more than half. When I say more than half, I mean it is 5 or more. 5, 6, 7, 8, 9. This number is more than half. So when you take 1 from here, add it to this, it will be 4. So we're going to get 486.4. 100 falls here. And this is more than half. So when we borrow 1 from here, we add it to the 6, making 7. So we're going to get 486.37 or 486.37. And then to the nearest 1,000, it falls on 8. Now this is half. When you borrow 1 from here, it will be 9. And therefore we're going to get 486.369. Illustration 2. Correct 0.0605368 to the nearest 1,000. 1,000 falls here. 1,000 will be here. 10, 100, and 1,000. This is 5. When you borrow 1 from here, it will be 1. Therefore, you get 0.061. To the nearest tenth. Tenth is here. When you borrow 1 from here, this is more than half. So when you borrow 1 from here, it will be 1. So it will be 0.1. To the nearest hundreds is 6. 10, 100, 1,000. So 100 is 6. But this is less than half. So we don't borrow anything from this number. So we just write 0.06. Illustration 3. Round 2 Ghana cedis 75 pesos to the nearest city. In the solution to the nearest city, we consider the next number after 2. And this is more than half. So when we take 1 from here and add it, making 3. That is why we have 3 Ghana cedis. Finding a value of a digit in decimals. A boy measured his teacher's table and corrected the measurement as 12.34. What is the value of 4? This is 4. Remember, 10, 100. 10, 100. So 4 is hundreds. Illustration 2. What is the value of 5 in the number 78.523? 10, 100, 1,000. 10, so 5 is 10. So 5 tenths. BECE 2006. What is the value of the digit 9 in the number 624.93? 10, 100. So 9 is 9 tenths or 9 tenths in words. 2009 BECE. What is the value of 4 in the number 7,073.48? 10, 100. Therefore 4 is 10. So 4 tenths or 4 tenths. Differences between the round up and round down concepts. When we round up, we consider the larger number, whereas when rounding down, we consider the smaller of the two. So illustration 2, write 78.460478 as indicated in the table below. Round up. When we are rounding up, we consider the larger number. So we borrow 1 from here and add it to this, making 5. So it will be 78.5. That is it. Round off is the same thing. We are rounding it off. We consider the second larger number added to this, making 5. So we're going to get 78.5. Round down. When we are rounding down, we consider the smaller of the two. We are going to round down the smaller of the two. So 4 and 6, which one is smaller? 4 is smaller. So 78.4 as indicated here. To the nearest hundreds. Remember 10, 100, and 1000. So 10, 100. 100 falls on 6. Round up. When we are rounding up, we consider the larger number. So we add 1 to 6, making 7. So to be 78.47. Round off. When we are rounding it off, we consider the number here, but then the number here is not more than half, or it's not up to half, and therefore we throw everything away, and the final answer becomes 78.46 as it is indicated here. Round down. When we are rounding down, we consider the smaller of the two. So round down, these are the smaller numbers. Which of them is the smaller of the two? 0. So we don't borrow anything from here, but then we leave it as it is. And so we're going to get 78.46 as it is written here. The nearest 1000, it falls on 0. Round up, we consider the larger number. So we add 1 to 6. Sorry, we add 1 to the 0, making 1. So it's going to be 78.461. Round off. Here is not up to 5. So we just round it off. We don't borrow any number from here. So we're going to get 78.460 as indicated here. Round down, the same thing. When rounding down, we consider the smaller of the two, 4 and 7. Which of them is the smaller? Is 4. And 4 is not up to 5. And therefore we leave it out. And then we write 78.460. Review exercise 11. This is an example I've indicated here. Please try and then fill in the blank spaces. And then the next number becomes, the next question is 486.3482 to the nearest tens, hundreds, and ones. I've provided answers, but please try and then solve it on your own. Thank you for watching. Please subscribe, share, and enable notification. Thanks once again for watching. Bye-bye.